Hello, everyone. Welcome to our webinar on achieving extreme high availability in Postgres using multi-master architecture. Thank you for tuning in today. I'm your host, Annie, and today I have with me Hari Kiran, who is the Customer Success Evangelist at pgEdge, and Semab Tariq, who is the PostgreSQL Consultant at Stormatics, as the speakers for this webinar. Before we start the session, I would like to share the usual housekeeping items. This webinar is being recorded and the recording will be shared afterwards. Feel free to use the Q&A feature or the webinar chat for your queries. We have the Q&A segment near the end, so your questions will be answered at that time. And that's all from my end. Over to Semab and Hari. Good luck.
All right. Thank you, Annie. Great. Thank you, Annie, for the wonderful introduction. Yeah, let's get started. Recently we have been getting a lot of questions from customers about what multi-master architecture is and how it can actually help to achieve higher availability for their businesses. The thing is that it doesn't really matter that you are running a smaller business or you are running a huge, a larger enterprise. One thing you absolutely want to avoid is operational disruption, and you want to have minimal downtime for your businesses. Now, longer periods of downtime can really cost. Longer period of downtime can be really costly, not in terms of revenue, but in terms of reputation as well. And we do not, of course, want this to be happen with our businesses. So this is where multi-master replication actually become very important. It helps you to distribute the workload to the multiple nodes and reduce the chances of the failure. So without further ado, let's get started. So this is a kind of an agenda about what we are going to talk in today's session. So first of all, we are going to cover key differences between multi-master versus single master architecture. And then we are going to talk about what are the main methods available in Postgres in terms of replication. And then we are going to explore more about multi-master architecture. And then we are going to talk about some tools that can be helped to actually monitor and implement multi-master architectures. And finally, we will conclude our presentation with by mentioning a couple of effective best practices or strategies for taking backups. So yeah, let's get started.
Yeah. Thank you so much, Annie and Semab. On behalf of pgEdge team, we really thank you for conducting this webinar. Good day to everybody who have tuned into the webinar. While we are looking at single master and multi-master, we look at the core differentiating factors. Right? And if you can see on the screen, we've got a single master setup on the left hand and on the right hand side. Right? Now, we dive into what are all some of the primary aspects that from a Postgres MMR architecture standpoint, we will have to take into account. Right? The basic things are the foundational or the building blocks are the compute, reads and writes, storage, and how many nodes are we set up? What is the exact shared versus silo storage that we have? Right? In a single instance, single master instance, all compute operations are handled by one primary node. Right? So you look at wherever the transactions are coming from. Right? Now this means that the primary node handles both read and writes. Which can create a bottleneck, in systems where we are talking about a super busy transactions per second, right? With high traffic and or resource intensive queries. If you look at the MMR, the multi-master architecture, right? The compute resources are distributed across multiple nodes, right? Each master node can handle both read-write operations. So the moment I say each master can look at handling both read-write operations, you are looking at how many number of nodes could I be doing, right? How many number of nodes could I be, provisioning in one availability zone, in one region where the concentration of my user base is, right? This actually offers greater compute scalability and then enormous number of options, also looking at eliminating a single point of failure, right? That's the compute scalability that we are looking at. And the read writes that we have in place, right? So all writes are redirected to one master node, as I mentioned, right? Read operations can be done, distributed to replicas. Depends on how many replicas you have. Depends on how some of the Postgres parameters like hot standby feedback, hot standbys that you have, right? The complexity and ensuring the data consistency across these nodes, right? If the nodes are spread across multiple regions, your single master instance tends to be slower, and then your vacuum operations gets kind of a stalled, so your performance goes for a toss. So fast forward to multi-master application, it allows both reads and writes, right? So significantly improving both performance and the types of operations, right? The types of operations and the use cases your application demands. The architecture itself, reduces latency, which I will be touching upon, with a reference of how we do the zero latency or reduced latencies by balancing workloads across several nodes, right? This is from offering better redundancy in case of any node failures, right? Again, this is pointing to the point, the failures or the single point of failures that we have, right? And moving on from the computes, the reads and writes, right? You look at the nodes and the storage that is required, right? Storage is typically centralized when we are talking about single master configurations, right? And again, one